For Chapter 11, Issue 3, we're going to go over the causes and effects of global warming and damage to the ozone layer, which are two separate problems. We're going to look at the causes and effects of regional and local scale air pollution and solid waste, and we'll compare and contrast point and non-point sources of water pollution. So basically we're looking at industrial waste and pollution. So why does industry cause pollution? First of all, air pollution is caused usually when we burn fossil fuels. There's other types of air pollution that can be caused through byproducts of industry, but the major ones have to do with burning coal, burning oil, or burning natural gas. So when we look at the major villains or the major air pollutants you need to know about, sulfur oxides, and there's more than one sulfur oxide. So for now, just SOx, sulfur oxides, and a little small x here stands for, it could be SO2 or SO3. So sulfur oxides come from coal. Nitrous oxides come from burning petroleum or oil, and they can also come from burning coal. Particulate matter is like soot. It's fine pieces of like smoke, and it comes mainly from burning coal, but also from burning oil, particularly like in the form of like diesel. Hydrocarbons are hydrogen bonded with carbon. So things like methane, and that comes from burning all fossil fuels. And carbon monoxide, which comes from burning all fossil fuels. But usually we think about carbon monoxide poisoning from natural gas or oil. Carbon dioxide is also now listed as a criteria pollutant by the EPA. So you could add CO2 to this list as well. So we'll start by looking at climate change and global warming. So when you look at climate change and global warming, you can see that as carbon dioxide increases, so as the parts per million of carbon dioxide in the atmosphere increases, so does the global air temperature. This phenomenon is known as global warming. So overall, the average temperature of the air and of the oceans has been increasing. This is caused by an increase in greenhouse gases. So carbon dioxide, carbon monoxide, methane, these are all greenhouse gases. And greenhouse gases trap in the Earth's thermal heat rays, so thermal energy from the sun, and it traps it into the troposphere. So this overall causes climate change. When we talk about climate change, we're referring to the overall change in global climatic patterns. When we burn fossil fuels, carbon dioxide is the big one we focus on. So CO2 levels in the atmosphere have risen by over 25% in the last 200 years. And because of that, we can predict the response of Earth's temperature because of the greenhouse effect, which again is well studied. We understand how the greenhouse affects how it works. What are the problems with climate change or global warming? And these are just some general ones. We'll get more into detail with it in the second half of the year. But the melting of the polar ice sheets. The melting of the polar ice sheets would lead to rising sea levels, which can cause flooding. And it can also cause something called salinization. So when salt water creeps into like freshwater aquifers. So it can salinize your drinking water. In other areas, increased temperature can lead to an increase in droughts. So increased Earth's surface temperature and atmosphere temperature might lead to an increase in dry weather. So you have an increase in droughts, which can lead to an increase in famines, although famines are not caused by drought alone. We know that you need unequal distribution of food resources. And it can also lead to an increase in wildfires, like we've seen across the United States. Other impacts of climate change involve an increase in the disease vector range. And so like mosquitoes spread diseases, and tropical mosquitoes, as their range is the area that they are able to survive in increases, you have an increase in diseases like malaria. You have Zika, which was a small disease in sub-Saharan Africa that people didn't really know about, make its way with mosquitoes over to Latin America, and then creep their way all the way up into Puerto Rico and the U.S. this year. You also have an increase in diseases like Ebola, because you're coming into contact with vectors we maybe normally wouldn't have. And we also have a shift of global precipitation patterns. So this could include things like El Nino effects being worsened, increased rain, increased flooding, inland floodings, not flooding due to sea level rise, but increased flooding due to increased rain, increased droughts. And you might also see because of the warming sea temperatures, you might see an increase in the severity of storms like hurricanes. Ozone depletion is a completely separate issue from global warming. So the greenhouse effect takes place right here in the troposphere. So this is where the thermal energy from the sun is trapped. It's passed through infrared light. The ozone layer is right up here. It's in the stratosphere. So the ozone layer is made up of 3 oxygen molecules attached together. Chlorofluorocarbons were a coolant used in refrigeration, and they were also used to keep like aerosol cans from getting too warm when you were spraying with them. So they used to be in aerosol cans, although they haven't been since I was a small child. When you release chlorofluorocarbons into the atmosphere, this man-made chemical, the chlorine separates in the stratosphere from the fluorine and the carbon. And so that chlorine molecule then attaches to an ozone molecule and pulls it apart. So that one chlorine molecule can attach to like 10,000 ozone molecules, breaking it from O3 into O2. Ozone, O3, blocks UV light penetration. UV light penetration isn't warm, so it's not about heat here. It's about UV light penetrating, more UV light penetrating through our atmosphere, and UV light can cause mutations in DNA. That's why UV light can be used as a way to sanitize something, because it can kill the bacteria and the viruses by mutating their cells and breaking them down. So this hole in the ozone layer was really a bunch of O2 molecules that led to an increased amount of UV light. Again, it's caused by chlorofluorocarbons. It doesn't impact the temperature of the earth. It doesn't have anything really to do with heat. So although chlorofluorocarbons can increase, they are definitely a greenhouse gas. The biggest problem with chlorofluorocarbons is that they were in the stratosphere breaking down ozone. The other thing about ozone depletion is that we've done a lot to fix this problem. In 1987, a document called the Montreal Protocol was signed. This Montreal Protocol banned CFCs in refrigerants and in aerosol cans across the world. And the U.S. really took the lead. You know, we looked at the research by scientists. It was coming out of mostly Berkeley, I believe, at the time. And we developed things called like hydrochlorofluorocarbons, so that hydrogen and chlorine are bonded together, so the chlorine can't then unattach from the fluoride and the carbons. So the hydrogen and chlorine are kind of bonded together, so it doesn't break apart the ozone molecules. So we came up with new coolants to use. So we made money. Our chemical industries made money. Our refrigeration companies made money. We really led the charge, and the ozone hole is shrinking. This is an environmental victory, and it's one that the U.S. kind of championed and led the way in. So it was a great success story for our country. Now, at a regional scale, so global climate change and ozone depletion, these are all like global scale problems, right? Small scale, because you're looking at zoomed out. At a larger scale, regional scale, we can look at things like acid deposition. So deposition is when it comes down. So we're looking at really acid precipitation, which is acid rain. And there's also dry acid deposition, which is when you're just you've got particulate matter with sulfur and nitrogen oxides in it. Acid rain is caused by burning coal, so sulfur oxides and nitrous oxides, and the burning of petroleum products. When the sulfur oxides or the nitrous oxides combine with water vapor, they basically make nitric or sulfuric acid. When it comes down in the form of precipitation, it can corrode buildings or wear away the sides of buildings, kill aquatic life, can damage plant leaves, reducing photosynthesis, and the hydronium ions and the acids bond to minerals like magnesium and chlorine. It bonds to clay particles, and so the soil doesn't hold on to nutrients as well. From a geography standpoint, acid rain does not fall over where it's emitted. So if you look at where acid rain is really falling, here we're putting out the gases, and it's blowing over. So like Canada gets a lot of acid rain from factories in New England. Here, this shows you the pathway for acid rain. So here you're burning probably a coal-fired power plant putting out sulfur oxides and nitrous oxides. Here you have vehicle exhaust putting out nitrous oxides. This here is acid particles is dry deposition, so just dry particulate matter that's acidic falling to the environment. And then here you have it going up into the clouds, being broken down with water vapor being transformed into nitric acid, and then falling back down to the earth. And since wind patterns move, it's going to get carried by the wind, and it's going to, affect areas that aren't really causing that type of pollution. So acid rain might be caused by factories over here, but might be impacting areas over here. So in the U.S., again, think air pollutants created in the Northeast can carry up to Canada and also can go out further west. Here's a forest that's been impacted by acid rain. So you can see the needles have burned off. So this plant is dying. It can't produce sugars. It can't produce energy. It's not absorbing carbon dioxide anymore. It's not putting out oxygen. When we look at local scale air pollution, we're looking at air pollution that's taking place within a city, usually within an urban area. And so when you have more condensed emissions, you're going to have more severe air pollution. The air pollution you're going to find in urban areas is made up of basically carbon monoxide, hydrocarbons, and particulates. Although in some places it can also be made up of nitrogen oxides. Something called a temperature inversion is when you have, so normally you have warm air, cooler air, right? The warm air is in the bottom, and as the warm air rises, the cold air sinks. When you have the warm air sandwiched between cool air, we call that a temperature inversion. And this traps air pollution right here near the surface. So temperature inversions lead to an increase in air pollution in urban areas. Here you can see a city with high rates of photochemical smog caused by vehicle exhaust and hydrocarbons. And here you see Mexico City on a clear day and on a smog day. What other kind of waste does industry cause? It makes solid waste pollution. About 2 kilograms of solid waste per person is generated in the U.S. every day. So each of us makes about 4 pounds of trash a day. 60% of our trash comes from residences and 40% from businesses. The most amount of garbage we throw away is paper. So it's the largest percentage of solid waste in the U.S. And most of our garbage is put into what's called a sanitary landfill. In a sanitary landfill, you have a plastic coating down here. Then you put your trash in compacted. You put earth layers over it, and then you seal it with plastic. And usually you have a little vent for the methane to escape.